Patrick from AI Tutor here, and surprise, surprise, I've got a bit of maths for you today. So we're doing some GCSE to carry on celebrating the fact that the AI Tutor GCSE course is sick. We've got Edexcel June 2018 and it's paper 2 today, so I believe I'm allowed a calculator. Let's crack on. Question 1, looks like we've got some indices flying about. So it says simplify m cubed times m to the 4. So this is a simple one, and the reason is because when we multiply these kind of powers like this, all we actually have to do is add the powers. So it's just going to be m to the 3 add 4, which is going to be m to the 7. Nothing too crazy there. Second one says simplify 5np cubed and then all of that cubed. So let me write that down. I've got 5np cubed and then all of that cubed. Now a classic mistake is people will realize that they need to do the p cubed and then they'll forget about the 5 and the n. The reason there is a bracket around all of this is because we need to do everything cubed. So to write this out in longhand, I would have to do 5 cubed times by n cubed times by p cubed. So 5 cubed is 125. I'll let you use your calculator for that though. N cubed is just n cubed. And then if I have a power raised to another power, I multiply the powers. So this is going to be p to the 3 times 3, which is p to the 9. Sick. Last one looks grim. I've got 32. Let's write it all out. 32q to the 9 r to the 4 over 4q cubed. It's even how to say r. Okay. So I basically want to look at each thing individually. I want to look at the numbers individually, the q's and the r's. Let's look at the numbers first of all. Do we get any nice cancellations? Well, we do, because 32 over 4 is just 8. So I know that the number is going to be an 8. And then let's look at the q's. I've got q to the 9 divided by q to the 3. So this is the opposite of this rule. If I'm dividing them, I just take the powers away. So it's going to be q to the 9 minus 3, which is going to be q to the 6. So I'll get q to the 6. And then r to the 4, I say minus. That is because I'm dividing by r. Now, r is just r to the 1 as a power. So I need to do 4 minus 1, which is 3. So it turns out now that all of this cancelled beautifully. I've not even got a fraction anymore, and that is going to be my final answer. Question 2, let's have it. Part A says find the lowest common multiple of 40 and 56. So there is a proper way to do this with getting the prime factorizations of both and then being all clever. I'm going to be a bit more lazy. So what we can do here is we can basically just kind of add up and get some different multiples of 40, get some different multiples of 56, and kind of see where we go. So 40 I can probably do without a calculator because it's a pretty easy number. 40, 80, 120, 160, 200, 240, 280, etc. Let's go there for now. 56, now we want to do the same thing, but remember, you've got a calculator, so don't worry. So we've got 56. I'm just going to get my calculator, and then I'm just going to keep adding lots of 56 here. So I get 112. So, and then basically, as soon as we find one that matches, then we're good. Add another 56, 168. Add another 56, 224. Add another 56, 280. Hello. Look at what we have here. We have a 280 here and a 280 here. It's as simple as that. So that's the answer here. There is a proper way to do this. Don't worry about it for now because we're talking exam technique. Part B says the following. Write down the highest common factor of A and B, where we are given the prime factorizations already. So now I am going to do the thing with prime factorizations. For the highest common factor, all we do is we just look at both of these prime factorizations. So we've got 2 cubed, 3 and 5, and we've got 2 squared, 3 and 5 squared. All we do is we choose all of the factors that appear in both of them. So for example, what does that mean? That means that a 3 appears in both of them. Now here we have 2 cubed and 2 squared. So 2 cubed doesn't appear in both of them because I've only got 2 squared here, but 2 squared does because obviously 2 squared times 2 is 2 cubed. So both of them have 2 squared in. And then this has got 5 squared, but 5 squared doesn't appear in both, does it? Because only 5 appears here. So 5 appears in both. So what does that tell us? That tells us that we have a 3 appearing in both, a 5 appearing in both, and a 2 squared appearing in both. That is the highest common factor. These are all of the factors that are common in both of these factorizations. So now we would literally just work that out. So if I was to do 3 times 5 times 2 squared on my calculator, that gets me 60, and that is going to be the highest common factor of A and B. 3. The line L is shown on the grid. Let's get the grid up. Sweet. Find an equation for L. All right, you know how to do this. It's all about y equals mx plus c. What is m? What is c? M is the gradient, c is the y-intercept. So c straight away is just wherever this thing hits the y-axis. Boom, it's going to be 6. M is the gradient. So the gradient is the change in y over change in x. And what I can do is I can use 2 nice points to kind of work this out. So in other words, the question is, if I go 1 up in the x, how much does it go up in y? So look, if I go 1 up in the x, I go 3 up in y. And that's going to happen anywhere, isn't it? 1 up in x, 3 up in y. In other words, the gradient is 3. So simply put, the equation of this line is y equals m, which we know to be 3x, plus the y-intercept. Well, the y-intercept is actually going to be minus 6 here. So instead of writing plus, I'm going to write minus 6. Question 4. Raya buys a van for £8,500 plus VAT at 20%. Raya pays a deposit for the van. She then pays the rest of the cost in 12 equal payments of a pretty random £531.25 each month. Find the ratio of the deposit Raya pays to the total of the 12 equal payments. Give your answer in its simplest form. Okay, there's a few tasks here. First task is we need the total cost of the van. Because look at the first sentence. It's 8,500 quid plus 20%. So let's do that before we go on. So the total cost of the van is going to be 8,500 times by, and then how do I add 20% to something? I multiply it by 1.2. The 1 is the 100%, and then the 0.2 is the extra 20%. Let's work that out. So on your calculator, if you do 8,500 times 1.2, that gets you £10,200. That is the total cost. She then pays a deposit for the van, and then the rest in 12 equal payments of £531.25. So you might ask yourself the question, well, in total, how much did she spend on those 12 equal payments? What would we do? We would do 12 lots of the monthly payment, £531.25. Let's work that out. 12 times by £531.25 equals the following. If I can learn how to use my calculator, there we go, £6,375. Brilliant. So we know the total cost of the van. We know how much she paid off in the monthly payments. So then the question is, how much did she pay in the deposit? Well, it's going to be the difference between these two things. So I've got my total 10,200. And that is going to be split between the equal payments and the deposit. The deposit is just going to be this minus this. So 10,200 minus answer is 3,825. Okay, so this is your ratio, isn't it? The ratio of the deposit to that is going to be 3,825 to 6,375. Obviously, I'm going to be able to cancel this down a bit. So if I was to do this, what I can do is I can get my calculator and I can do 6,375 divided by 3,825. And that's going to really nicely cancel down to 5 over 3 here. That means that this is the same as 3 to 5, and that's my final answer. Let's have a look at question 5. Complete the table of values for y equals x squared minus x minus 6. Okay, well, let's get this table of values up. Pretty simple, right? We know y in terms of x, so all we have to do is take each x value and then sub it into the equation to get y. So for minus 2, what I need to do on my calculator, I'm going to do minus 2 squared. Make sure there's a bracket around the minus 2 here. That is super important. So minus 2 in a bracket, then squared. And then minus x, so minus 2, minus 6. And that is going to get me 0. Let's do exactly the same thing with minus 1. Because I've already got this on my calculator, I'm just going to swap all of these instances of minus 2 with a minus 1 here. So I don't actually have to write it all out again. So it's going to look like minus 1 squared minus minus 1 minus 6. And that is going to get me minus 4. I want to do the same with 1, 2, and 3. And again, I am just going to swap the instances here. So 1 squared minus 1 minus 6, that's minus 6. 2 squared minus 2 minus 6, minus 4. And 3. So 3 squared minus 3 minus 6. And that is going to get me 0. Brilliant. Okay, how am I going to do this then? Part B says on the grid, draw the graph of this thing from the values of -3 to 3. So here's the grid. So, well, first of all, what we can do is we can just plot these points, right? So x is -3, y is 6. That is this here. X is -2, y is 0. So -2 here, 0 here. X is -1, y is -4. So that's going to be down here. X is 0, y is -6 is going to be down here. X is 1, y is -6 is going to be here. X is 2, y is -4 is going to be here. And 3 and 0 is going to be here. So we can kind of see we're getting this nice smiley face, this parabola. And we know that's correct because that's what quadratics look like. So basically, all you need to do is just do a relatively reasonable line. This is quite hard on a graphics tablet, but we're going for it down here. Like, gorgeous, isn't it? Gorgeous. If you've got the points in the right place, it doesn't need to be this beautiful line. The examiner knows what you're on about, so that's completely acceptable. The third part of the question says use your graph to find estimates of the solutions to the equation x squared minus x minus 6 equals -2. Okay. Look at the left-hand side of this equation. Is that relevant? Of course it is, because that's the graph that we have drawn. So the x squared minus x minus 6 is this red line. So if we want to find out when that is equal to -2, all I need to do, let me write this down so you can see the connection between the algebra and the graph here. This is x squared minus x minus 6 in red. And then I'm going to have another number here, this -2. Let's put that in green. So I need to find out, I've got the red, sketch the green, find out where they're equal to each other. So the green is going to be y equals -2, which is quite simply this right here. Now I need to do, okay, well my solutions to this are going to be where they intersect. It's going to be right here and right here. And again, because this line is just drawn kind of freehand, there's going to be a slight, there's going to be a range of acceptable answers here. Okay, so this to me, let's have a look. This is -1, this is -2. So this line in the middle is going to be -1.5. And then I look to be 1 to the left of that. So I reckon a good example of that would be -1.6. Let's do the second one. Okay, this is 2, this is 3. So this is going to be 2.5. And again, it looks like I'm actually kind of between the 2.5 and the next one. So I would say 2.55 for that case. And that is how you get the estimations for this equation. Let's go. A force of 70 newtons acts on an area of 20 centimeters squared. The force has increased by 10. The area has increased by 10. Helen says the pressure decreases by less than 20%. Is she correct? So you might be scared by this question. You're like, what's this question on about? But essentially, imagine the question just says this, right? Work out the pressure, and then, force has increased, area has increased, work out the new pressure. That's what you need to do here. So it's just this kind of little bit of like looking at the exam question and actually being like, what's it on about? But that's it. So they could completely, change the wording of this question and it'd be the exact same thing. You just need to realize what they're asking. So essentially, look, we're given the equation for pressure. Why don't we work out the old pressure, work out the new pressure, and then we can work out the kind of percentage change. I think that's a reasonable thing to do. So, old pressure. What do we do? Well, the old force divided by the old area, nothing too crazy. So, force, 70, divided by area, which is 20. Simple, right? Which is going to be 7/2 or 3.5. Nothing too crazy. New pressure, the force has increased by 10. So it's now, instead of 70, it's going to be 80. And the area is also increased by 10. So instead of 20, it's going to be 30. Which is going to be 8/3, or as a nice little decimal, we're going to go for 2.66 recurring. Because I don't want to round that, let's just go for 8/3 for now. Okay, now it says the pressure decreases by less than 20%. Okay, so the question is, what is the new pressure as a percentage of the old pressure? Because then we can work out the percentage difference. So how are we going to do that? We're going to do the new pressure divided by the old pressure times by 100. And that is going to tell us what the percentage is. So new pressure, which you know what? I've actually got stored on my calculator as amps. So if I do amps divided by 3.5 times 100, that gets me the following. 76.19% Okay, so the new pressure is 76% of the old pressure. In other words, it has decreased. So the pressure has decreased by how much? Well, essentially the difference between 100 and 76. So I'll say about, because I've rounded here, but it's decreased by about 24%, hasn't it? Which is more than 20%. So Helen is incorrect, right? She's wrong. Because she thinks that it decreased by less than 20, but we know that it actually decreased by more than 20. Question 7. Enlarge shape A by scale factor a third, center 0.1. Let's get it up on the whiteboard. So the key thing here is that sometimes people see the word enlarge and they always think it has to get bigger. But it turns out that if the scale factor is less than 1, it's actually going to get smaller. So the way we do this is we look at the vertices, or corners for normal people, right? So what we need to do is we need to take the distance from the center of enlargement, which they have kindly denoted for us here, and each corner. And then we need to do that same distance, but multiplied by the scale factor. That gets us the new corresponding corner. Let me show you what I mean. Here is a line between the center and one of the corners. We can see that it kind of goes 3 diagonally, doesn't it? It goes like 1, 2, 3. So if I times that by a third, I'm just going to get 1. In other words, the new point is just going to be 1 away. So it's going to be right there. We do the same thing for all of them, and the shape is going to just build itself. So this one here, look at this corner. I'm not going to do a line because it's just going to go over all of this. But if you look at it, it's going to be 1, 2, 3, 4, 5, 6 diagonal squares away. Times that by a third, that's 6 times a third, or 2. So the new corner for that, so this was the first one. The new corner for that is going to be 2 away. So that is going to be here, or it's going to be this right here. Okay, so I've got 2 corners here already. Let's go for the next one. So what do? I draw a line all the way here. Okay, let's have a think about how far this is away. It's going to be 1, 2, 3 horizontally, and then it's going to be all from 1 to 10, so 9 vertically. So I need to third those. So it's going to be 1 horizontally and 3 vertically. So it's going to be 1 and then 3 up here, and it's going to become this one here. So you might already see kind of how this shape is going to work out, but just in case you don't, I'm going to do the last one for you as well. So again, I want to do the line all the way to here. So what happens? Well, it goes 6 horizontally and again 9 vertically. So I need to third both of those. So I want it to go 2 horizontally and I want it to go 3 vertically. That is going to take me to here, meaning that my last vertex is going to be here. So I can see the shape right here. Now, just so it doesn't get, I'm going to draw the shape for you and then I'm going to take away the lines just so you're not overloaded. So the shape is going to look like this. And then let's just get rid of these lines so it's very obvious. That's what the new shape is going to look like. And you can see here that it's exactly the same shape as A, but it's basically 3 times smaller, isn't it? And that is how you do enlargements. Question 8, and it looks like we've got a bit of probability. So let me read the question and then talk about a good way to approach it. So we've got 60 people and they want to go on a holiday in Britain, Spain or Italy. No idea why you would pick Britain. 38 of the people were male, 11 of the 32 people who said Britain were female. You get a load of information, whatever. One of the females is chosen at random. What's the probability that this female said Spain? Okay, so much information, right? We've got kind of 2 different variables that we're testing here. On the one hand, we've got male or female. And then on the other hand, we've got like Britain, Spain or Italy. So a great way of getting all of this information together is with a 2-way table, okay? So what we can do is we can kind of have a bit of a table popping off like this. And what I can have is I can have one of the variables up here and another one here. So for example, I could do the following. I could have my males and my females like this. And then I could have Britain, Spain or Italy here. What I can also do is I can have columns and rows for the totals as well. So for example, I could have total here. So let's put T in for total, and T for total. And now all of these little nuggets of information that I've been given, I can start filling in. For example, in total, there are 60 people. So that's going to be here. That's like the total of the totals, okay? 38 of them were male. So in total, the amount of males, 38 of them. And I go filling in the information like this. 11 of the 32 people who said Britain were female. We've been given 2 bits of information there. The first bit is, well, 11 of them were female. But the second bit is that in total, 32 people chose Britain. Right, so this is the total for Britain. 8 males said Italy. So that's going to be 8 Italy male. 12 people said Spain. I don't know about the males and female, but I know that the total amount of people who said Spain were 12. So now what I can do is, given all the other bits of information, I can kind of work it out from there. For example, there's 38 males, but there's 60 people in total. That means there must be 60 minus 38, or 22 females. We go on like that. Here, okay, there's 60 people in total. 32 Britain, 12 Spain. We can work out how many Italy. If I do 60 minus 32 minus 12, that gets me 16, which is the people who prefer to go to Italy. And then I can say, well, 16 in total for Italy, but I know that 8 males like Italy. So that means that 8 females must like Italy, right? 16 minus 8, and I keep going like this. What about this one here? In total, there are 22 females, 11 like Britain, 8 like Italy, so that's 19 in total. So there must be 3 that like Spain. Now, it turns out that this is enough information to actually answer the question, but just for completeness, I'm going to fill in this table just so you know how we do it. We can use these totals here, right? I know that 12 people like Spain, only 3 are female, so I must have 9 males here. I know that 32 people like Britain, so there's 32 in total that like Britain, so 32 minus 11 is going to get me 21. So now I know absolutely everything. Now, anything I ask or get asked, I can really easily answer. Oh, what's the probability male in Spain? Boom. Male in Italy? Boom. You know what I mean? Female in Britain? Boom. Very simple. Let's have a look. One of the females is chosen at random. Okay. This is important. This is what we call kind of conditional probability. So we want the probability that the female said Spain, but we don't just look at this and say, okay, 60 people in total, 3 over 60. The reason is we already know that this is a female. So the question you should actually ask is, what is the probability that the person likes Spain given that they're a female? That's important. So the given that they're a female, that basically closes in your kind of area of reference. Given that they're a female means I don't care about any of the males. So we do this. We say, you know what? These are the females. You can almost rub out all of this out of your mind. The only thing I care about is what is in this red box at this point. So that's the given that they're a female bit. Now, given that they're a female, what's the probability that they said Spain? Okay, well now I say, well look, there's 3 of them that said Spain, and then there's a total, remember the total is this now, so there's a total of 22 of them. And that is going to be your answer, 3 over 22. Bit of money. Jean invests 12 grand in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. At the end of the first year, the value of Jean's investment is £12,336. Okay. In the second year, the rate of interest is X over 2%. In other words, the interest is halved. What is the value of Jean's investment at the end of the 2 years? There's 2 tasks. The first thing is we need X, don't we? There's no way we're going to answer this question without X. We've got to get X somehow. And then once we do that, we need to work out the value after 2 years. So let's look at the first kind of half of this. It says the interest rate is X for the first year. Starts off with 12k. Has some interest applied to it, X%, and then ends up with 12,336. What we can do is we can, right, if I want to kind of, just like I did a couple of questions ago, I added 20% to something, the VAT. And for that, I times it by 1.2, right? So what I can do is I can work out whatever this kind of multiplier is. And from that, I can work out what the interest rate is. So let me show you. Let's call this multiplier, right? M. How am I going to rearrange this equation to get M? I'm going to divide by 12,000. So my M is going to be 12,336 over 12k. Let's work out what that is. That is going to be 1.028. Perfect. Okay. Let me ask you, What does that correspond to as a percentage increase? Well, this is always the 100%. So if it was like 1.1, it would be, that's our 10, so that would be like 10%. This is going to be a 2.8% increase. So x is going to be 2.8 here. If I want to add, increase something by 2.8, I need to multiply it by 1.028. If it was 1.28, it would be 28%. Cool. Now we know x. We can say, well, all we need to do now, we have the value after the first year. What's the interest rate for the next year? It's going to be x over 2, which is going to be 1.4. So all I need to do is take the value at the end of the first year, multiply it by the thing that would correspond to a 1.4% increase, and that's going to be my answer. What would correspond to a 1.4% increase? It's going to be 1.014. That's 2.8, that's 1.4. All I do now, 12,336 times by 1.014, and that gets me my final answer as 12508.704. Remember, because this is money, it would be useful to round to 2 decimal places because that's pence. So in this case, I've got 0.4. I'm going to round that down. So that is going to be £12,508.70. Question 10, what we got? The vector A and the vector B are shown on the grid. On the grid, draw and label the vector minus 2a. Let's get the grid up. Okay, vectors, right? Magnitude, direction. So we can clearly see that A has kind of a size or magnitude of like this, right? Of 1 across and 2 up. And it goes in that direction. It kind of goes up. So 2a, just thinking about the magnitude, it's going to be this line, but twice as long, right? So it's going to be this line, and then there's going to be another one. So that is going to be the size of 2a, and it doesn't matter where I put it here. So let's put it here. That's 2a. But then the question is, what about the direction? Because it says draw and label the vector minus 2a. So minus flips the direction. So a goes up that way, minus is going to go down this way. And that is going to be minus 2. Woo! Whiteboard, mate. What's popping off here? That's going to be minus 2a. Sweet. Work out a plus 2b as a column vector. Okay, well, let's work out a and b as column vectors first, and then I can work out a plus 2b. As a column vector, it's basically just what's on the x, what's on the y. A goes 1 positive in the x and 2 positive in the y. So that is A as a column vector. B goes 1 positive in the x, but then it goes down in the y, doesn't it? And by 3. So that's going to be minus 3. Now we'll just do algebra on this. So A plus 2b is therefore going to equal plus 2 lots of 1 minus 3. I can put this all in one column vector. This is going to be 1 and then plus 2 times 1, so that's 2, so 1 plus 2. And then the bottom bit is going to be 2, and then 2 times minus 3 is minus 6, that's going to be minus 6. Therefore, the final answer is going to be 1 plus 2, which is 3, 2 minus 6, which is minus 4, and that is algebra with column vectors. 11, we should be getting to the halfway point. So, f and g are functions, and f of x is 2 over x squared, g of x is 4x cubed. And the first part, pretty simple, just says find f of minus 5. So this is classic function notation, and all it means is swap the x's with a minus 5. So if f of x is 2 over x squared, f of minus 5 is just going to be 2 over minus 5 squared. Nothing too crazy about that. Be careful about the brackets. You need a bracket here, because if you don't, the minus sign wouldn't get squared and it would be incorrect. So minus 5 squared is positive 25. So the answer to this is just simply 2 over 25. Done. Part B says find fg of 1. So this is a bit more going on here. This is what we call composite functions, right? So the way I like to write fg of 1 is to actually put another bracket here, because now it makes a bit more sense in terms of function notation. What this means is put g of 1 into f. Just like here, we put minus 5 into f. We just want to put g of 1 into f. So we're going to do two things. We're first of all just going to find out what g of 1 is, and then we're just going to shove it in that there. So g of 1, well, what's that? That's just going to be swapping the x's in g of x with a 1. So it's going to be 4 times by 1 cubed. And that is going to be 4, because 1 cubed is 1. So now we're ready to say, okay, well that means that fg of 1 is just going to be f of 4. And we know how to do this because it's just like we did in part A. It's going to be 2 divided by 4 squared. And this is going to be 2 over 16 or 1 over 8. And that is going to be your answer to question 11. I've just stuck question 12 straight on the whiteboard because it's an interactive one. So we've got 4 graphs here, and then it's about proportionality, right? So it says the graphs of y against x represent 4 different types of proportionality. Match each type of proportionality to the table in the graph. So this is more actually knowledge about graphs more than proportionality. I suppose for proportionality, you do need to realize that if I have this kind of fish, then it basically means that y equals some constant times by x. Or if I have it like this, it's exactly the same thing. It just means that y is equal to k over x. That I think most people know. The trouble with this question is actually just knowing what these graphs look like. So I think B is the easiest because B is a straight line. It's a linear graph. Linear graphs look like this, right? So in other words, this is going to be the y is just proportional to x, okay? So this is going to be B. X squared, we're going to need to know generally what x squareds look like. Well, they're parabolas, aren't they? So they can kind of look like that, or they can look like that. So do any of those match that in this case? Well, that doesn't. This doesn't, does it? And this doesn't either, but this does, because this could kind of carry on like that. So that means that D is going to be the x squared one. Let's do the square root of x one. So square root of x, they go up together, right? Like as x gets bigger, the square root of x gets bigger, but the square root of x gets bigger slowly, okay? So that's going to be graph A, because what happens is x is going up, but y is kind of tapering off a bit like that. So it's going up, but slower than x. So that is going to be A, and then the last one, process of elimination, is going to be C, but the reason is because the graph of 1 over x essentially looks like this. It's a reciprocal graph, right? As x goes up, y goes down. So as x gets massive, y gets closer and closer to 0, but never quite hits it, and vice versa. As x gets closer to 0, y goes up to infinity, but again, never quite hits it. So the answer to this question is just going to be B, D, A, C. Question 13 looks like we've got a circle theorem, which we all know can be very problematic. So, what are we going to do for this one? Let's give it a read, and let's hope we don't give up. So, A, B, C, D are points on the circumference of a circle, centre O. FD is a tangent to the circle. Show that y minus x equals 90. Give reason for each stage you're working. Okay, let's get this diagram up. So, there's a lot going on here. What I would recommend, don't think that you're going to find the perfect kind of method or way to do this instantly. Just get as much information that you know or can remember about circle theorems on this, and then the more you see angles, then you might be like, oh no, wait a minute, isn't that blah 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 blah. So I might write some stuff on this now that I technically don't need for the question, but the more information I have, the easier it is for me to see something. So one circle theorem that I always seem to remember is that the radius is always perpendicular to the tangent. Is that going to help us? Maybe, maybe not. I don't know, but let's get it down. So this is a radius because the centre is O, and then I've got this tangent here, EDF. That means that this is going to be a right angle here, and then so is that. That might help me, might not, who knows. We also know that cyclic quadrilaterals, so a four-sided shape within a circle, in other words, like A, B, C, D here, where all of the points are on the circumference, opposite angles add up to 180. So like I've got a Y here, the opposite angle is the one at C, so this would be 180 minus Y. So they both add up to 180. Is that going to help me? Maybe, maybe not, who knows. What else? Well, if I was to make a triangle, here, this kind of OBD, this would be isosceles because this is a radius and this is also a radius. Meaning that if this angle is X, then this angle here is going to be X as well. That might help me. And then I'm also noticing another circle theorem come out of this, and that is that if I have an angle here, this angle in the middle is going to be double that. So the angle at the centre is always twice the angle right at the circumference here, meaning it wouldn't be this angle, it would be this kind of reflex, this big angle here. So that would mean the following. That would mean that this angle, this massive one here, is going to be 2y. I've got a lot of information on this. I probably don't need it all, but I am noticing the thing that I've just done could help me out a lot here. And the reason is because if this is 2y, that would get me this angle here, wouldn't it? Because obviously the whole circle's 360, so this is going to be 360 minus 2y. That is useful because I've now got some information that relates both x and y. Look at this triangle OBD. I've got all of the angles in it, haven't I? I've got an x, and I've got a 360 minus 2y. So all of those angles must add together to make what? 180, because they're in a triangle. And I think I'm sorted here. So if I do my 360 minus 2y, add my two lots of x, they must all add together to make 180. Okay, so take 180 from both sides. I'm going to get 180 minus 2y plus 2x equals 0, right? 360 minus 180 is 180. Let's add the 2y to both sides. Minus 2x from both sides. I'm going to get 2y minus 2x equals 180. Divide everything by 2, and I'm going to get y minus x equals 90. Brilliant. In an exam, I would probably just be, every time I kind of did something like this, I would write, the circle theorem. Radius is perpendicular to tangent. Angles in a cyclic quadrilateral, blah, 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 blah. Just to make sure, just because they say, give a reason. Okay, but that's part A. What about part B? It says Dylan was asked to give some possible values for x and y. Let's see if we can kind of fit in over here. He said y could be 200 and x would be 110 because 200 minus 110 equals 90. So I suppose he's trying to use this kind of y minus x equals 90 thing. Is he correct? You must give a reason for your answer. Would it make sense for y to be 200? Let's look at y. Y is this. So the first thing we can notice is that it's less than 180 degrees, isn't it? Because 180 degrees is this straight line and y is clearly less than that. The second thing is it's an angle within a triangle, isn't it? This triangle here, we know that all of these angles must add up to make 180. So if y itself is greater than 180, that would just be impossible, wouldn't it? So it's not true here. So I would say impossible, because y is inside a triangle. So basically must be less than 180 degrees. 200 is clearly not less than 180, so this is not possible. Question 14, the distance time graph shows information about part of a car journey. Distance traveled, time, makes sense. Use the graph to estimate the speed of the car at time 5 seconds. Okay, two pieces of information that they are testing here. The first being that the gradient of a distance time graph is speed, right? Because speed is like distance over time. So it's basically, how quickly is the distance changing as time goes on? That is your speed. The second thing you need to notice is that you can estimate gradients of these graphs by drawing a tangent. So here's the thing, the gradient of this graph is the speed, but this graph isn't a straight line. The gradient keeps changing, right? So for example, the gradient here is something, but then it's a bit more here, a bit more here. So in A level, you can actually use something called calculus to work out the proper value of the gradient. But at GCSE, what we do is we estimate this by drawing a tangent. So 5 seconds is here, okay, on the graph. We're going to want to estimate a tangent, and then the reason they say estimate is because I'm just going to draw a straight line here. You're going to get your ruler and literally draw it. There's obviously going to be a bit of margin for error, isn't there? So here's what I'm going to do. Tangents obviously just touch the graph kind of at that one point and then go off in both directions. So for example, if I was to do that, that is incorrect. What I need to do is I need to get it right kind of on the same level as the graph at that point. So let's give it a go. That maybe I want to make it go up a tiny bit more, so maybe I want to go, no, maybe a bit less. So that's the thing, it's a lot easier with your ruler because you can actually just twist it like that. I think that's fine, okay? As I say, there's going to be an acceptable range of answers here. So this is my tangent, right? This is my estimation of a tangent at that point. Now I can work out the gradient of this straight line, and then that will be my estimate for the speed. Okay, so what I can do for this straight line, I can just take 2 points on it. Why don't I take some end points here? So why don't I take, or a point that nicely actually goes on one of the squares. So maybe that, and why don't I go for that? Just because they're both on proper squares, so there's almost less estimation involved. Now, gradients are always changing y by changing x, so in this case, they're changing the distance over the change in time. Okay, so this, the y value for this, let's get in there. This is going to be the following. So this is 60 and this is 80. There's 5 squares between them, meaning that each square is going to be 4. So I'm 1 above 60, so that's going to be 64. Minus the y coordinate of this, which is going to be what? That's 2 squares up, so that is going to be 8. The difference in time is going to be the following. This is going to be 2 squares after 7. 7 and 8 is 5 squares, so each one's going to be 0.2. So this is going to be 7.4. And then this one here is going to be 3 after 3, I believe, so that's going to be 3.6. So this is the calculation that I now need for my gradient. Straight into your calculator. 64 minus 8 over 7.4 minus 3.6. And that is going to get me 14.721 decimal place. What is the unit here? Well, it's meters over seconds. So this is going to be meters per second. A darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on the Saturday, the probability they will win on the Sunday is 0.67. If they don't win on the Saturday, the probability that they'll win on Sunday is 0.35. So this is kind of conditional probability. And what it means is that one event affects another event, right? If you win on Saturday, you know, the team's got a bit more confidence, bit of morale. And then on Sunday, you've got a higher chance of winning. If you lose on Saturday, you're feeling a bit bad. You're probably going to play worse on the Sunday. So they're not independent. The events affect each other. And something that's really useful for kind of putting that on a diagram is a tree diagram. Because we can really kind of follow the different possibilities and be like win, lose, etc. So let's get this tree diagram up here. Let's see what happens, right? So this is, the start. Then we play Saturday's game. The probability of winning is 0.45, as we've already been told here. And now here, this is basically what happens on Sunday, given that we already won on the Saturday. Okay, so given that we won on the Saturday, we're told the probability of winning on Sunday is 0.67. Cool. And then the only other thing that can happen is not win. So these two probabilities must add up to 1. So to get the probability of losing on Sunday, not winning, maybe you can draw, then it's going to be 1 minus 0.67. That is going to be 0.33. Let's go back here. What's the probability of not winning if the probability of winning is 0.45? Again, 1 minus 0.45, that's 0.55. Okay, given that you didn't win on Saturday, what's the probability of winning on Sunday? We are told that it's 0.35. So therefore, the probability of not winning is going to be 1 minus 0.35 or 0.65. Fantastic. Find the probability that the team will win exactly one of the two matches. So now we have this tree diagram, we can say, okay, there's essentially 4 different things that can happen. I can win, 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 not win, not win, win, and not win, not win. And you can follow these branches, right? So when they ask for something like one of the two matches, I literally even colour it in. Be like, what are the branches that kind of satisfy this? Exactly one of them. Well, win, win, that doesn't work because that's winning 2 of them. Win, not win works because I've only won 1. So what I can do is I can literally just do something like that to show, okay, that's one of them that I need to take into account. Not win and then win, well, yeah, that's winning 1 match, so let's highlight that one as well. And then not win, that's not winning any. So the 2 branches that we care about are this one and this one. We can work out the probability of these things happening now. What you do is you just multiply these events, right? So the probability of this branch is going to be 0.45 multiplied by 0.33. The probability of this branch is going to be 0.55 multiplied by 0.35. Let's work out those 2 things quickly. So 0.45 times 0.33 is 0.1485. And the second one, 0.55 times 0.35 is 0.1925. So the probability of winning exactly 1 match, well, it could be this, or it could be this. So this is the OR rule here. If it's OR probabilities, we add them together. This was the AND rule, wasn't it? Because it's saying, what's the probability of winning the first and not winning the second? I multiply. And now it's, well, what's the probability of this happening or this happening? I add them together. So the probability that I want in the end, I'm going to do the 0.1925, which we just got. So ants in my calculator. Add that to the 0.1485 from the first bit. And that's going to get my final probability as 0.341. On the grid, draw the graph of x squared plus y squared equals 12.25. Let's get this grid up. Okay, you need to know about equations and geometry here. It turns out that if I have a graph of the form x squared plus y squared equals something, so I'm going to write r squared here and you'll see why. This is going to be a circle. The center of the circle is going to be the origin, right, 0, 0. And then whatever's on the right-hand side is going to be the radius of this circle squared. In other words, if I have 12.25, that tells me that the radius of this circle, if I square it, I'm going to get 12.25. In other words, if I square root 12.25, which I'm going to do now, that's going to get me the radius. And the radius is 7 over 2, or 3.5. So what I know is I have a circle here, center here, radius 3.5. So if you think about the radius here, it's going to go, this is 3, so it's going to go to kind of here, and then it's going to go to, 3.5 on all of these axes. So again, that is going to be here. And I'm going to try and draw a circle going through these points. It's probably going to be ugly. You, in reality, would have a compass. I can't put a compass on my computer screen, unfortunately. So I'm going to try and wing it somehow, but we'll see how it goes. So let's have a look. 3.5, again, between 3 and 4, about here. 3 is here. Between 3 and 4, that's going to be about here. Okay, I'm going to try and do this with a circle tool. It's probably going to go very badly. You can see that this was... could be worse. Could be worse. Let's make it a bit smaller. Again, this is never going to be perfect if I'm doing it on my computer. I think that's about as good as I'm going to get using this software. So it's going to be a circle, center of the origin, radius 3.5. Brilliant. Part B says, hence find estimates for the solutions of the simultaneous equation. The first one that they're given is the one that we've just got, this thing in red, x squared plus y squared equals 12.25. And the second one is 2x plus y equals 1. That's a circle. So 2x plus y equals 1. So why does it say hence? We're obviously going to use what we've just done. We're going to use the graph. Because if I was to sketch both of these graphs, the intersections would be where the solutions of the simultaneous equations are. So how am I going to sketch this? Well, if I was to take 2x from both sides, I would get y equals minus 2x plus 1. If you compare that to y equals mx plus c, I know that c is at 1, c, the y-intercept, is at 1. And the gradient is going to be minus 2 here. So for every 1 I go up in x, I go minus 2 down in y. So I can make a graph out of this, because if I go 1 up in x, I go minus 2 in y. 1 up in x, minus 2 in y. So what I can do now is I can draw a line going through these points. Let's give it a go maybe from here. Just like that, I reckon, is good enough for a slight estimate. So now I just need to find where these two things intersect. So let's have a quick look. It's going to be this point here and this point here. I'm going to zoom in for this. So this top one, let's go straight in. So, okay, it looks like the following. I'm about here and here. Okay, so this is going to be minus 1. This is going to be minus 1.2 on the x. And then that's going to be 3.2 on the y. So minus 1.2, 3.2. Let's just write that here quickly. And then the other one is going to be, okay, so this looks to be kind of in between 2 points. It looks to be in between these two here. So that's going to be, that would be 1.8. So in the middle it would be 1.9. This one here looks to be minus 2.8. So 1.9 minus 2.8. 1.9 minus 2.8. Okay, so these coordinates are going to be the x values and the y values. So the solutions are going to be x equals minus 1.2 and y equals 3.2. Again, estimates. Or x equals 1.9 and y equals minus 2.8. You need to remember that solutions of the simultaneous equations are where the graphs intersect. Question 17, and it looks like the stats has begun, so we're just going to have to grin and bear it, okay? So we've got a histogram. Now, in histograms, the area of each block, I'm not going to say it's equal to the frequency. I'm going to say it's proportional to the frequency. Now, in a lot of cases, it is equal, okay? But there's kind of a constant of proportionality. In a lot of cases, that is 1. Now, we can check what that is from the piece of information that we have here. Once we find that out, then we can work out the rest of the frequencies. So the area of this block, well, it's 5 across and then 0.8 up, isn't it? So 5 times 0.8 would get us the area, and that happens to be 4, which is the same as the frequency. That means for this histogram, each of these blocks, the area is just going to represent the frequency. I go more into this on AI Tutor because that can be a bit confusing. All I need to do now is just work out the area of each of these, put it in the frequency. Going to be super simple. So this has a width of 10 and a height of 0.4. 10 times 0.4, 4. This has a width of 10 and a height of 0.6. 10 times 0.6, 6. This has a width of 5 and a height of 1. 5 times 1, 5. This has a width of 20 and a height of 0.2. 20 times 0.2, 4. Sick. Part B says calculate an estimate for the lower quartile of the times taken to finish the puzzle. Okay, we need the total frequency first, right? So I'm going to add up all of these. So I'm going to get 4 plus 4 plus 6 plus 5 plus 4, which is going to be 23. You can use calculator, don't worry about that. So, okay, the lower quartile, it's almost like, I've got all my 23 here. The median is going to be here. The lower quartile is going to be here. It's going to be like the median of the lower bit. And because this is an odd number, I'm going to add 1 to this and divide it by 4, okay, to get where the lower quartile is going to lie. Again, there's a lot more on this on AI Tutor. I don't want to go into too much detail right now. That is going to be 6. So I'm essentially looking for the 6th person here from this kind of frequency, from this kind of frequency, from the histogram really. And then that's going to be my estimate. It's going to be an estimate because I have grouped data. I don't exactly have, okay, I'm right here, essentially. Okay, so let's have a look at this, right? There's 4 people in this one, and then there's another 4 here. So if you were to think, I get 4 here, and then I get 4 here, where would the 6th person lie? Well, my 4th person is here, and then my 8th person is here. So my 6th person, if you were to assume that kind of within this class, they're basically just uniformly over here, the 6th person would lie right in the middle of them. In other words, the 6th person is going to basically have an estimate of 10. So my lower quartile here is going to be 10, and I believe this is minutes, 10 minutes. I don't know that this is the case. This is an estimate. I don't know that the 6th person has 10 minutes. It's just that I know that there's 4 of them between 5 and 15. That's the best estimate I can come up with. I went through that a bit quickly. This is called linear interpolation. There's a lot more on that on AI Tutor. It's just I don't want to go through the whole detail of it right now. But that is it for 17. 18, we got a cuboid. We got AB as 7.3. So let's start getting this on the diagram. We got a 7.3 over here. What else we got? CH. That is that. So that's the height of the thing. That's going to be an 8.1. We got BCA, which is So if I was to draw a line here, we are told that this bad boy is 48 degrees, like this. Find the size of the angle between AH, so AH is this, and the plane ABCD. Okay, so let's draw AH. That is going to be this big old diagonal. Okay, and we want the angle between that and the plane ABCD. So if we were to kind of make a triangle here, the angle that we want is basically this, okay? That is the angle between AH and the plane. The plane is just the base, the bottom bit. So this is our end goal here, this here. Okay, so we know that we should kind of be using trig here. Basically, I've got an angle, well, I want this angle. I've got one of the lengths. If I could just get one more of these lengths, I would have enough information to kind of do a SOHCAHTOA to get this green angle here. Okay, so how can I use the other bits of information that I have? Think of this triangle here. I'm going to draw a triangle in green. Why not? Let's just go funky with the colours. Look at this. The reason I'm drawing a triangle here is because I've got one of the sides, I've got one of the angles, and then this other side, this hypotenuse, is actually part of the other triangle. So this is going to be super useful. So I'm going to draw this green triangle kind of outside here, just so you actually have an idea about what's popping off, okay? So the hypotenuse of this green triangle is AC, essentially. And then I've got a 7.3 here. and then you can see that I've got this 48. I'm going to try and use this information to get the hypotenuse, which would essentially be AC. Okay, so let's write SOHCAHTOA. Let's see what we have here. I want the hypotenuse, and I have the opposite, because this is opposite the angle. Hypotenuse, opposite, sine is the thing that I care about here. So if I was to do sine of my angle, sine of 48, equals opposite, so the 7.3 divided by hypotenuse, that gets me my hypotenuse as 7.3 over sine 48. Let's work u out quickly. Just need to put my calculator into degrees again. Okay, so 7.3 divided by sine 48 is going to be 9.823 dot 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 dot. 9.823 dot dot dot. I'm writing dot 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 because I'm ideally just going to use ants in my calculator when I put this into another calculation. This tells me that this thing here is my 9.823. So now if I was to draw out this bigger triangle, what am I going to get? I'm going to get this height of 8.1. The hypotenuse I don't know because that's AH. But I do know this bit now, because this bit is the hypotenuse that we just worked out. So that is my 9.823 blah 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 blah, and I want this angle here. So that, if I SOHCAHTOA, I've got the opposite and the adjacent, so I'm going to be using tan here. I'm going to get tan alpha, or theta, or whatever this angle is going to be the opposite over adjacent, so I just want a bit more space here. Okay, so basically my angle, well, I'm going to get tan, let's call you theta, why not, equals opposite 8.1 over my adjacent 9.8 blah blah blah. So my angle is going to be the inverse tan of this thing, of my 8.1 over my 9.8 blah 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 blah, and I've got the bottom bit in my calculator already. So let's work it out. If I'm going to do the inverse tan, and then I'm going to write 8.1 divided by ants, and that is going to get me my answer as 39.5 degrees. I'm liking the look of question 19. So we've got a shape S, and it is 1/4 of a solid sphere, centre O. We're told the volume of this thing, right? It's 576 pi, and we want the surface area. Woo! Okay, there's a few things popping off here. The first thing to realise is that we do not have the radius, okay? Like, look, we're given a formula for the surface area of a sphere in terms of the radius. If I ain't got the radius, I ain't getting the surface area. Can we use the fact that we've been given the volume of this thing to work out the radius? I think we can, because the volume of a sphere is 4 over 3 pi r cubed. But we've only got a quarter, right? So what is the volume of a quarter of a sphere? Well, it's going to be a quarter of 4 over 3 pi r cubed. So 4 over 3 divided by 4, well, that's 1 over 3, right? So 1 over 3 pi r cubed is going to be 576 pi, because that is, that is going to be the volume of a quarter sphere. We're told the volume of this quarter sphere is that, so let's work this out from here. Well, I can cancel the pi's. If I was to multiply by 3, I'm going to get r cubed equals 3 times 576. And then to get r, I need to do the cube root of that. So r is going to be the cube root of 3 times 576, which I have no idea what is, by the way. So let's get that on my calculator. So the cube root, 3 times 576, is going to be a lovely 12. Okay, we're getting there. R is 12. Okay, let's go back to this thing. We're told the surface area of a sphere is 4 pi r squared. But it's not going to be as simple as the volume here and just say, oh, divide that by 4. Because if you think about it, if I had a sphere, that surface area is just going to be that outer bit. But because I've cut this up, the surface area of S, I get kind of a quarter of the sphere here, but then I've also got these two pieces, right, that are essentially these two flat bits. So what I could do is I could work out the curved surface area, which is just going to be a quarter of this surface area formula. And then I'm going to add that to these two other bits. So let's do that first. So the curved part, let's say the curved surface area of S, that is going to equal a quarter of the formula for the surface area of a sphere, isn't it? Because I've got a quarter of it. So a quarter of 4 pi r squared is just going to be pi r squared, isn't it? Pi, we know that r is 12, so that's going to be 12 squared. So that's going to be 144 pi. Okay, now let's look at these other bits. I've essentially got 2 semicircles, haven't I? So if I have 2 semicircles, surely that's just the same as having 1 circle. If I was to put these 2 semicircles together, I'd get 1 circle. Okay, but we know the radius of this circle, don't we? It's the same radius of the sphere. So I've got the radius is 12. 1 circle, isn't that also just pi r squared, the area of a circle? So the other 2 bits put together are going to be another lot of pi r squared, right? So the other 2 bits is going to be pi times 12 squared again, which is again 144 pi. So my final answer, so the total, is just going to be these 2 things added together. So it's going to be 288 pi. But we want it to 3 significant figures, so let's work out what that is. 288 pi, I'm going to press SD, and that is going to get me to 3 significant figures, 905, and then this is centimeters squared. Question 20, we're getting there. So first one, Martin did a question, right? And he was asked to rationalize the denominator of 14 over 2 plus root 3. So we know that we need to multiply by almost the conjugate of the bottom. In other words, we need to swap the sign on the bottom, multiply top and bottom by that. So that's what he did. He multiplied by 2 minus root 3, which is correct. So that first line is good. I do 14 times by 2 minus root 3, and then 2 plus root 3 times 2 minus root 3. Nothing too crazy so far. Next line. Then we multiply it out. So if I was to multiply out the 14 and the 2 minus root 3, I would get 14 times 2, which is 28. 14 times minus root 3, which is minus 14 root 3. So that looks good. The bottom. So if I was to multiply out the bottom, just so you can see what I'm thinking here, let's multiply this out. I would do this times this, so I'd get 4. I would do this times this, so I'd get minus 2 root 3. I would get this times this, so I'd get plus 2 root 3. And then what would this be? This would be root 3 times root 3, which is 3, but then plus minus, that would make minus. But look what Martin did. Martin did all of that, but the last thing, he added 3 instead of taking it away. That's his mistake. So Martin's mistake is that. It's basically in the second line, he added the 3 instead of taking it away. And that is more than enough for 1 mark. I've shown what it should be. It's only 1 mark. I've identified exactly where his mistake is. Cool. So now we've got another question in part B, and it's another rationalizing of the denominator. So here we need to multiply top and bottom by root 12, which looks good. He then said that it was the following: 5 times 3 root 2. So he's essentially saying that root 12 is 3 root 2. Is it? Let's find out. So root 12, well, that is the following. That's going to be 3 times 4, isn't it? And then this is going to be root 3 times root 4. Root 3 is just root 3, but root 4 is 2. So this is going to be 2 root 3. But he said it was 3 root 2. So we could say the following. We could say, so again, it's the kind of second line. It basically should be 2 root 3, but he wrote 3 root 2. That's basically it. 2 root 3, and then let's just say, but it says, again, given that you've done all of this stuff, you've probably got the mark, but it's just making sure the examiner knows exactly what you're on about. But that's everything for question 20. We have made it to the last question. We got Buddy Old Jackson trying to find the density of a block of wood, as you do. It's in the shape of a cuboid, which is good to know, and he measures the length, width, and the height, and the mass, and then all to the nearest something or other. By considering bounds, work out the density of the wood, giving your answer to a suitable degree of accuracy. Okay, few things to look at here. The first thing is, what is density? Density is mass over volume, okay? So something is really dense if it's really heavy, but it's quite small, kind of thing. In the case of a cuboid, what is volume? Well, it's just going to be the length and the width and the height all times together. So in the case of this cuboid, the density is going to be mass over length, width, height. My game plan is the following. I would like to work out an upper bound and a lower bound for density. Once I have those two numbers, I can start thinking about the answer to a suitable degree of accuracy. I think something nice will come out once we have the numbers. To do all of that, let's first of all work out the upper and lower bounds for all of these individual components of this formula. So the length, the width, the height, and the mass. So length, well, all of these three things are to the nearest millimeter. So the bounds will be as follows. So I'm going to say, they have to be between these two numbers. The lower bound for length is going to be 13.15. Upper is going to be 13.25. Because that 0.2 is the millimeter. A millimeter is a tenth of a centimeter. So on a similar note, this is going to be 15.95, 16.05. Height, 21.65 and 21.75. Now, mass is a bit different because it's correct to the nearest 5 grams. So if you almost kind of half that, that's going to be 2.5 grams. So this is going to be 1967.5. Let's get a bit more space here. And then 1972.5 are going to be the values that round to the nearest 5 gram to 1970. Okay. How would I work out a lower bound for the density here? Look at this equation. If I want this to be as small as possible, I would want the mass to be as small as possible because it's on the top of the fraction, but I would want the thing on the bottom to be as big as possible, wouldn't I? Because if I'm dividing by a bigger number, that's going to make the whole fraction smaller. So, to get the lower bound for the density, I'm going to take the lower bound for the mass, which is 1967.5, but then I'm going to take the upper bounds for all of these things. So this is going to be 13.25 times 16.05 times 21.75. Let's work that out quickly. Let's stick it here. So get your calculator out. 1967.5 over 13.25 times 16.05 times by 21.75, getting me 0.4253 blah de blah de blah. Okay, let's do the same thing but for the upper bound. Let's keep this equation in shot because this is important. Upper bound. I'm going to want the mass to be as big as possible. And I'm going to want everything on the bottom of the fraction to be as small as possible. So the upper bound is going to be 1972.5 over all of the lower bounds now for these three things. So 13.15, 15.95, and 21.65. And that is going to get me the following. Oh, there's so many numbers. Okay, 1972.5 over 13.15. 15.95, 21.65, and that is going to get me 0.43438 blah de blah de blah. Okay, now this is the suitable degree of accuracy bit. Look at these two numbers. We know that these are the extremes, right? Really the density is going to be somewhere in between, but on the extremes, the smallest it can possibly be is 0.4253 and then the biggest it can possibly be is 0.434 Imagine I was to round these two things to two significant figures. What would they both round to? So to two significant figures, or two decimal places, which in this case is the same thing, the lower bound to two significant figures would be 0.43, because that's going to round up. But the upper bound would also be 0.43, because that's going to round down. So here's the thing. Even though we've taken these two extremes, once you round to two significant figures, they're both exactly the same. Meaning that with confidence, we can say that to two significant figures, we know that the density is going to be this, right? Because even both of the extremes both go to it. So yes, if I go, they're going to divert once I go further, more accuracy, right? 4, 5, 6 significant figures. But to two significant figures, I can say that the density is 0.43. What is going to be the unit? It's going to be grams per centimeters cubed. So my final answer is going to be that. And that is it for paper 2 for GCSE. Paper 3 will be out at some point soon. Make sure to like and subscribe. For the subscribers, I'm going to be doing some kind of gifts, which will probably include free AI Tutor Premium memberships. So do not miss out on that, and I will see you for paper 3.